Hey, Grandma here at MakeCode. Today we're going to talk about the program Elvis, a flamboyant snake in MakeCode Arcade. You can read all about this at our blog where the code is explained in detail. But just to get you started, we're doing this little YouTube video. Okay. Over there. Thank you. Okay, the main loop of the code. Well, actually, before we do that, I think I better show you this Elvis. Okay. Elvis. This is Elvis. So, do I want the snake to go faster? Well, if I press B, that's basically no. So, here we go. That's Elvis. I press B, he pauses. Okay. Elvis has, you remember Elvis, or at least I do, because Elvis was famous when I was in high school. He had this gorgeous big flop of black hair. He loved to wear pink and black, and he had blue suede shoes. And his diet, well, his favorite food was peanut butter and banana sandwiches, and sometimes he added bacon. So the idea of this game is that Elvis moves at a fixed rate, and you change his direction by using these arrow keys. Now, if you want to pause Elvis, you use the B key, and to start him back, you use the B key again. Now, if Elvis hits the wall, the game is over. If Elvis turns back on himself, for example, turning his head completely around by pressing the key opposite to the direction he's moving, the game ends. Or if he makes a loop by looping around back onto his body, the game also ends. Now, the score is how many sandwiches Elvis has eaten by the time the game ends. Now, that sounds easy, but the problem is that every time Elvis eats a sandwich, he gets longer by one of these blocks, which is 8 pixels, 8 by 8 pixels. So eventually, if you're really good, Elvis can get so long that you can't hardly move around the screen without colliding with himself. So that's what makes the game really hard. Well, let's just keep on moving here a bit. Now there's always, now notice each time Elvis eats a sandwich, notice he got longer. Now also, each time he eats a sandwich, if there are fewer than 4 sandwiches on the screen already, the game will generate either 2 or 3 more sandwiches. So you'll never get the screen completely cluttered with sandwiches, because I think the most you can get using this algorithm is 5 or 6. So, but watch as and here we go, getting longer. Now, if you get tired of Elvis going so slow, you can start the game in a faster mode, which is definitely not the grandma mode. Oops, we hit the screen. Oh well, okay, now you have the idea of Elvis. Now, let's look at the code for Elvis. Well, every game has sort of a main loop. I guess they do. Well, maybe not, but anyway, the games I program generally have a main loop. And the game is played by this code defines the main flow of the game. It's kind of the game big picture. Let's see if I can get it a little bigger. Nope, can't. Okay. So notice that all these blocks on start, on game update, on button pressed, and on overlap, these are all on things, which mean that they happen in response to something happening in the game. On start runs when the game starts and is never run again after that. On game update runs every so many milliseconds. Well, it runs at every snake frequency milliseconds. And you remember at the beginning of the game, we ask the user whether they want to go use a faster snake, and that adjusts the snake frequency time. Then these orange keys are what the player does. The player can move the snake up, right, down, or left. And basically they just set a direction variable, and that variable is used down here when we call move snake every so many milliseconds. Now, so in other words, the snake moves in the direction of the last direction key that was pressed. Now this on B button pauses the snake or makes the snake go if it was already paused. This on overlap block is when the snake head intersects food. The only food, of course, is peanut butter and banana sandwiches. So when this overlap occurs, and we can think of this as a collision, but the problem with collision is you would think that when the two edges touch, this happens, but in my observation, it doesn't seem to be that way. Overlap is more descriptive because I don't seem to know quite when this event occurs relative to where the two sprites are. You didn't want to know all that. And what happens in this, when the head overlaps the food, chomp, 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 he eats the sandwich. Well, eating the sandwich means you increase the score by 1, play a tone, so you give some user some feedback. You destroy the food because, like, he ate it. You change the number of sandwiches on the screen by -1. You lengthen the snake by 1 sprite. You make the snake longer, and you call make sandwiches, so it throws out some more sandwiches on the screen. Now, these two ons overlaps in the game. Well, one time you can end the game, one way, is to have the snake head intersect the snake body. So that can happen when the snake turns back around on itself, or when his head intersects his body like he's going in a loop, and it bang, he runs into himself. Now, this one is really hard to prevent when the snake gets really long. So as the game goes along, it gets harder and harder to find a way around the screen to the sandwiches when the snake is everywhere. Okay, so this one is when the snake hits the wall. I mean, actually, it's not a wall. Hits the edge of the screen, it also ends. Now, I did this in a way, well, when I first programmed this, I didn't know about the on destroy and the setting the sprite to auto destroy. So I didn't use it. Well, late in the game, I figured that out, and I tried to add it to the game and replace this whole thing with an on destroy, but I got caught in an arcade transition between sprite kind legacy and sprite kind, and I could not add this code add the new code in blocks. Basically, it didn't work because I'd had sprite kind legacy in there, and the new sprites that were added were sprite kind, and you don't want to know all that, but basically it just did not work. Well, so you might say, well, why didn't I go to JavaScript and fix it? Well, I did, and there's 2 ways to fix it: by making them all sprite kinds or all sprite kind legacy. Both of those worked. I tested them, and guess what? I couldn't go back to blocks, and that's a bug. So, in fact, well, I won't bore you. If you want to know more about it, you can go to Discord and read about it. So, I will eventually re-release this game with a better implementation of checking for the border. Okay, that's the main game flow. Basically, this is the initialization. This happens every few milliseconds. These orange blocks are what the player does, and these are this block overlap scores, and these two in the game. Now and that's all of it. Well, except for you have to think about these functions. So let's look at what these functions are. This one, in the onStart, which is initialization, we call make the snake, and we call make the sandwiches, and we call make the borders, which, as I explained, eventually I won't need. And then we call get the snake speed from the player. Now, why do I have this BGO thing here? Well, notice that on-game update runs every so many milliseconds. And I don't want it to run if onStart isn't finished. And I also don't want it to run to move the snake if I'm over here in this lengthening the snake, because I found that worked out different ways at different times. In other words, it's a race condition and you don't want to do that. So basically I want to prevent this from running and this from running when I'm still making the initialization. I didn't say that right. I want to prevent this from running when I'm still in onStart or when I'm still in this scoring thing where the snake gets lengthened. So now, why this make the snake? Well, I only have to make the snake one time. Why did I make it into a function? Well, if I had put all the code required to make the snake in line here, this would have gone on for screen after screen after screen, and you couldn't even get it all on the same screen at the same time, and you absolutely could not understand it. So one of the main reasons for making functions isn't so that the code can be reused, it's so that you can express the code in a concise way so that you can understand it. Now this is understandable. Make the snake, make the sandwiches. So rather than have that code in line. I've also found that the comment feature of MakeCode when you're using blocks is practically useless, because either you open them all up and it clutters up the screen, or you close them all up and they're not there. So this function names also serve as documentation. So, and notice my function names are long and very descriptive. So I don't want you to be confused about what my functions do. So I fully describe them in the name. Now, why do I use underscores in my functions? Because you could use what's called camel case, which I see in a lot of the MakeCode examples. Camel case means that you start every word in caps, like make, then sandwiches would be capital S and you wouldn't have the underscore. Well, hey, I'm old and I can't read that very well with it all strung together. So I like using underscore so that I can clearly read it. Now, so we know what the onStart does, we know what the game update does, and all these the button presses set the snake direction to up, left, right, sideways. This pauses the game, and this is scoring when the head and the sandwiches intersect, and this is how the game ends, hitting the wall or hitting itself. So to understand the rest of this, all we have to do is look at each of the functions that are called here. There's not that many of them, but guess what? Some of these functions call other functions, so it goes on for a while. Okay, let's move right along and look at some of those. First, we're going to start with some easy ones. This is make sandwiches. Well, make sandwiches, first it runs only, it does it only if there's fewer than 4 sandwiches on the screen. If there's already 5 or 6, 4, 5, 6, it doesn't make any more because the screen gets too cluttered. Then it makes either 2 or 3 sandwiches, depending randomly. And to make a sandwich, all it does is set the sandwich sprite to that, and it's of kind food. Well, where did I get that peanut butter sandwich sprite image? I drew it, geez, and oh, it's so incredible. I'm not an artist, okay, but it seems to work. Now, where do I want to put the sandwich? Well, X, I'm going to pick a random position on the screen, anywhere from towards the edge of the screen, about 8, because I don't want part of the sandwich to be off the screen. And the sandwich is 8 pixels. It is 8 pixels, isn't it? Nope, 16. Okay, so I don't want it to be off the screen. And I want the Y to be similarly somewhere between 8 and the other side of the screen, the up and down. Okay, then I set the position of the sandwich sprite to the randomly generated X and Y, and I changed the number of sandwiches by N. That's all there is to it. Okay, next. Well, next we're going to make us some borders. And as I explained earlier, we wouldn't really need to make borders if I could use the auto destroy feature along with on destroy event. Well, but right now I need to make borders, and sometimes you might need to make borders anyway. So how do I do that? Well, I'm going to put the borders in an array. And a border sprite is screen width and height 1. So in other words, all of these are going to be 1 pixel either wide or tall, depending on whether they're, horizontal or vertical. They're going to be of kind border. And I'm going to set the position. I put them in the array here, and then I set their position to wherever that one was designed to be. So I do that for 4 borders. Then at the end, lazy thing that I am, I have a little loop here, which I like this kind of loop where it's for element. You use value, which is a variable in the loop, and of all the border sprites, and the border sprites is this array, and it fills each one of those little boogers with that color. Notice that value and value, so basically the value is a parameter of the loop. So it goes through each of the sprites and colors them. Okay, that was fun. Moving right along here. Next, we're going to make the snake. Now, this is the incredibly fun part of this program. Everything to do with the snake is the kind of the hard part of this program. But I thought the hard part was really fun because of lots of puzzles to solve. So, making the snake. Well, first, how many pixels square is the snake going to be? Well, the cell side is 8, so that's 8 pixels. Now, you might think you could change the size of the snake sprite by changing this to 10 or 12 or 16, but I started out planning to do it that way. Trouble was, there were places in the code where it turned out to be more challenging than I wanted to deal with at the time to allow that to be a variable. So although it uses a variable here, there are other places in the code where basically I have to assume how many pixels wide the snake, square the snake is, so you can't actually change this. And what MakeSnake does, well, it makes the head, it makes the body, and it sets the snake direction to up, which is 0. Now, when you make the snake body, I wanted to experiment, well, how many verticals did I want versus how many horizontal body sprites? So I experimented, and I ultimately decided to make it 4 and 4. So that's why I have these nice parameters here. Now, the snake speed. Remember at the very beginning of the program, it asked the player if it wanted a faster snake. Well, this was called up at the beginning in the on start. And if it wants a faster snake, then I set the move frequency to 300. If I want the regular old snake, I set it to 500. That's milliseconds, so that would be half a second. Now I call this the grandma speed, and this is the granddaughter speed. And if you're really good, you could futz with this and make it 100. I tried that, and basically if you blink, the snake is off the screen. Okay, now we're going to make the snake head is the next step. Well, making the snake head is pretty easy. It's a single sprite, but there are 4 images depending on which way the snake is going, because his head might be going up, he might be looking up, might be looking left, blah, 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 blah. So I set the head up to this image. I set the head down to, look at that, I clone it. And then I flip it, and that makes the down, and then I have another one which I did from scratch, and then I cloned it, and I flipped it. Flip that. So I have all my heads, 4 heads, images. Now, I start out with setting the head to head up, and that's because I set the direction to 0, which means up, so those have to be compatible. And I set the snake head to, I create the snake head sprite by using the snake head image, which I had just set to heads up, and it's of kind snake head sprite. Now, I set the snake Y to, basically I position it on the screen. I futzed with exactly where I want that head to be positioned. Well, notice it's midway, but I add about 10 to it. So it's a little further down than midway. Now, why didn't I set the X? Well, if you don't set it, it's in the middle. So that is a handy thing to know. That's why if you don't set the X and Y of a sprite, it appears in the middle. Actually, I should say its middle appears in the middle of the screen. Now, making the head body is quite a bit harder than making the head, because the body has lots of body sprites. And in fact, the body sprites are kind of in a chain, and the number of them vary, and you have to move them as the snake moves. Of course, it's easy to move the head because it's just one sprite. You just change its X and Y and it's moved. But it's more complicated to move the body because you have a variable number of sprites. So what this routine does is it first of all makes a snake body cell image. So it makes an 8 by 8 pixel, which I'll show you in a moment, that is going to be used repeatedly for the little cells in the snake body. And we're going to set the blue suede shoes to a blue image, which may go on a sprite, may go on a body sprite, or this sprite might be on the body sprite, but okay. Now, we're going to have a snake list, and the snake list is a list of snake body sprites. So in that list, we're going to keep track of which sprite's in front, which sprite's after it, and which sprite is to the left, and blah, 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 blah. So each of those sprites in here have an XY position, and that lets us figure out how to move the snake by rearranging the order of the sprite body cells while we change the X and Y appropriately of the individual sprites. And we have a way to avoid moving every sprite in the array, and we'll see that later. Now these two loops, this loop, notice we're going to vary the Y as we go through here, which means we create the cells of the loop that go down. Then once that's finished, we start and we set the cells, we vary X and we set the cells of the loop that go left. So we have a vertical segment and then we have a horizontal segment, and that's how you build the snake. Each one of these calls add body sprites to end, and it passes as variables the position of the sprite. So it's the snake head X here because you want the vertical to be in line with the snake head, but Y varies, so you want the Y to be going down. And same here, okay. Now the very last thing you do is put the shoes on the last body sprite. So that just means change this image to blue, to that blue suede shoes. Now this is where we make the sprite body cell image. This is pretty simple. To do that, we set this image and we create a square image of cell size. We set a variable cell size -1 to that, and the reason for that is, you'll see down here, and we fill the snake body image with black, and then we draw diagonal lines, so up, up, and that's where I needed this -1 number, because again it starts at 0, so we need the -1, and I make those pink because Elvis liked to dress in pink and black Now, adding the body sprite to the end. That's the thing that was called up in making the snake body, and it has parameters X and Y. We set the last body sprite, it's a variable, which you just use really kind of temporarily, to this sprite body image of kind snake body sprite. We set the last snake sprite position, that's what we just created here, to X and Y that was passed. And then we add that sprite to the end. Now, we didn't need to necessarily introduce this variable. It's like a temp, but rather than just work with the referencing the sprite in the array, which is a little more confusing, it's better to name this so that you really understand what you're doing. Well, how do you know it's the last one? Well, look, you added the thing to the end. So you added a new sprite to the end of the snake. An end means the last sprite in the array. That's the definition. Now, we move the snake. Now this, remember, that is called by the on-game update loop. And so this is really, really, really important. And it turns out it's got some fun puzzles in it. So let's look at this here. Move the snake. Well, we're going to, in order to move the snake, the basic idea is that you have a head followed by these body sprites. Well, we're going to move the head in some direction, depending on how that direction was set. We're going to move it up, left, right, or maybe even down, assuming the snake, well, if you move it down and the snake body is down, that's the end of the game. But you're going to move the snake some direction. Now, when you move the head, it leaves a space where the sprites need to move up to fill that space. And also, when you move the snake, the end sprite needs to come off. It could just be destroyed. But what I do, because I don't want to mess around with destroy and creating sprites, I just move the end sprite up to that needed sprite. So I'm recycling my sprites, but I have to change the X and Y plus the image on the sprite that was moved. And you'll see that in a minute. So to move the snake, we move the snake head. We then move the last body sprite to where the head was. And we then put the shoes on the new last body sprite, because when we move the last one, that means there are no shoes on it because the shoes was on the one that you moved. So we have to put the shoes on the last body sprite. Okay. Now, move the snake head. Well, there's two things you do when you have to move the snake head. One is you have to change the snake head position, which is this, and two, you have to change the snake head image. Well, those two things are the same in each case, but they depend a little bit on what direction the snake was going. So this first one, if the snake direction was 0, that's up. If the snake direction is 1, that is right. Well, so each of these is a little bit different. So the X and Y, remember we remembered the old position. So this is moving the snake head up because we subtracted from the Y, from the old position Y to the cell size, or 8. That moves it up one cell in the Y direction. Then we set the snake head image to up. Now each one of these does the same thing, varying only by the position the head was moved. Now when the head was moved, it left a space where there is no sprite in the snake. So what we have to do is here, we're going to move the last body sprite to where the head was. So to do that, we insert at 0 in the snake list. Okay. And then what do we okay. What is it at 0? Well, what we want at 0 is the very first body sprite, and so that's the one where right now there's a hole, there's nothing there, and so we get and remove the last value in the snake list, which is the shoes. Basically, it's the last sprite in the list, which is colored, has the shoes image. So we've got a new sprite in the position that we want it, and we recycle the old sprite. Then we're going to change that sprite's position to where the head was. That's head X prior and head Y prior. And then we want to set the image of that moved sprite to snake body image, because we don't want the shoes to be on the neck. Well, you could, but I mean, I did that, but I didn't look so good. And now to put the shoes on, which is the next thing called, all we have to do is we're going to get this last body sprite, which is in the snake list, and it's at the length of the sprite list -1. I don't have to tell you why it's -1. Well, it's because the first cell in the first array or list element is at 0. Therefore, the last one has to be at the length of the array -1. And we set the last snake sprite to blue suede shoes. That's all there is to that. Now, the very last function in the game is fun. And I will have to say, this is pretty clever. I had some ways of doing this which are much more convoluted, and then I discovered this way of doing it, and I felt so cool. Now, let's see what it does. Lengthen it by 1. Well, I needed a couple of little variables here. Okay, let me give you the idea first. The problem in lengthening the snake is, so if the last two cells in the snake were forming a vertical line, then you want to lengthen the snake at the end sprite, but either on a vertical line. You want to keep it on the vertical line. If the last two sprites in the tail were horizontal in position to each other, you want the new sprite to be placed horizontally and to the left or the right, depending on where the snake was. So here's the way you do that. I make this variable called snake length -1, which is just obviously what it is, and you set the last body sprite to, you get that sprite out of there. So now we've got a sprite here to work with. And then we also need a variable snake length -2, so that's the last two sprites. And then we get that sprite, which is the body next to the last sprite. So we have the last sprite and the next to the last sprite. Then we're going to call dx and dy by subtracting the two x positions and the two y positions. D stands for delta x, delta y, or, basically it's the directed distance in the x and the y coordinates. You didn't want to know that. You can easily figure this out by doing an example. You don't need to understand the math, sort of, but if you just get some graph paper and try an example, it will be clear why it's done this way. Then now dx and dy can be positive or negative, depending on whether these two coordinates are, depending on whether the end sprite is to the left or the right of the next to the end sprite, and similarly with dy. Then we can set the x of the last sprite to plus dx, and the y of the last body sprite to y plus dy. And you have to prove to yourself this works, but trust me, it works every time. And then we call this function we created before called add body sprite to the end. And we do this because we're lengthening the snake. So we add a body sprite. And then, of course, we put the shoes on the new last body sprite. Now, okay, that is Elvis. And I hope you enjoy playing Elvis. I do. And happy programming. This is Grandma at MakeCode, and I'll see you soon. Bye. Oh, I forgot. Please look at our blog. All this code is described in incredibly brilliant pictures and detail on our blog post. So thank you for watching.